Well, hello everyone. I guess I won't do the introduction because Jim so well covered it. But I, as we all know, really wanted to talk to you all about the next 50 years of science, marine science education, specifically at Shoals, but also with my experience. Which, as I'm thinking about it, might be a little strange given that I'll be speaking about this from the perspective having only been alive for 17 years. So, we will start with, there we go. We'll start with a little exercise. So I'd like you all to take 2 deep breaths, and I will join you. Okay, well, apologies for the dramatic presentation there. As you probably know, the oceans produce over 50% of the world's oxygen, which is remarkable to me as a young kid exploring the oceans and exploring reef ecosystems. Because I began thinking that what that means is essentially, without healthy oceans, we wouldn't have been able to take that second breath. Well, but I also discovered that coral reefs occupy less than 1% of the ocean floor, yet house over 25% of all marine species. That's why they're called the rainforests of the sea, and it's why they're also so vital to the entire ocean health, ocean ecosystem. Something else I discovered was that oceans, or reefs in particular, were dying at an unprecedented rate. As a matter of fact, the reef that I was snorkeling off of, as Jim mentioned, lost over 50% of its coral cover in 3 to 5 years. And 3.5 billion people globally depend on the oceans as their primary food source. So those facts having set the precedent, I want to tell you a little story. So about 10 years ago, I was snorkeling off the coast of Hawaii and was exploring my favorite reef, Kaikili Reef on West Maui. And I had really fallen in love with this environment, this ecosystem, because it was so different than the everyday life that I had come to know as a 6-year-old. And I fell in love with this environment, this oceanic environment. However, as I started to see the environmental degradation on this reef, as Jim mentioned, I felt personally, I'll call it attacked, because I had loved this ecosystem so much. I felt so at home in the ocean environment. So I wanted to do something about it. I decided to talk to scientists in the local environment, DLNR, EPA, and see what their needs were, specifically relating to this environment. I learned that there weren't enough scientists to monitor all of the marine ecosystems, not only in Hawaii, but also globally, as I'm sure we all know. Maybe whales are an exception, I now know. Let's see, is this? There we go. Okay, it's skipped one, but I'll still talk to it. Essentially, what I learned is that the difficulty was marine researchers couldn't adequately get to the field on a periodic basis to properly document, research, monitor these ecosystems, especially in Hawaii where resources were more limited. And so what I wanted to do was, if we couldn't bring the scientists to the ecosystem, maybe let's bring the ecosystem to the scientists. And that is what Jim has mentioned about these photos that I've collected. Essentially, what ReefQuest has done in the novel approach that we've taken is created 3D panoramic navigable environments of actual marine ecosystems so that citizen scientists or scientists can actually monitor these ecosystems on a periodic basis from their computer. So this is an example of one of those. There we go. This is an example of one of those ecosystems. This is also Kaikili Reef, and you can see the navigable environment on ReefQuest, reefquest.org. I don't know. There we go. So you might be wondering, how exactly do we, oh perfect, thank you. How exactly do we collect these transects? It starts with image collection. So ReefQuest volunteers, and Jim mentioned that there are over 60,000 of those. They go into the water, they go into the field, citizen scientists, curious volunteers, curious people, and they take thousands and thousands of images of various ecosystems, not only reef ecosystems, across the globe, 48 countries currently. They then upload it to a supercomputer that analyzes those images and creates a point cloud. Point cloud, if you don't know, essentially is a 3D map that searches for commonalities between images, and in finding those commonalities, stitches those images together, and if you apply it to the entire image set, will create a 3D navigable map of those common points. What you're then able to do is superimpose the images on top of that navigable map, creating the online implementation that you see here. What's remarkable about this system is that you essentially have the benefits of the resolution of a photoquadrate with the range of the video transect. And that is relatively unprecedented within documentation efforts. Another beauty of the system is that it's ordinary people, ordinary equipment, and minimal training required to collect this vast database. And so the 60,000 students, those are just curious people who want to contribute to the marine preservation, who are passionate about the marine world, and who want to pursue this on the side even. Another aspect is the variable refinement that is possible with this type of stitching. So you can see here on this platform, you can look at ecosystem, you can look at surveys all the way from the macroscopic views of the entire ecosystem health, all the way down, and I'm zooming in here to one of the mounding corals, to individual polyps. So you can conduct coral research anywhere from coral disease, growth anomalies, the list goes on. An example of one of those surveys that can be conducted on the virtual platform is the Coral Watch Coral Health Chart, or CARD, developed by the University of Queensland. And you can see how it's applied to this environment. It's a survey that quantifies, or relatively quantifies, reef health based on coral color and hue. And so this very simple survey applied to this database can actually provide very meaningful results to scientists within organizations like NOAA, EPA, Division of Land and Natural Resources, and the list goes on. You can see here, we call this the reef fingerprint. And essentially what this means, this is the data for Kaikili Reef that citizen scientists collected, spanning the history of the organization. And you can see that the very simple survey can actually yield very meaningful results, anywhere from biodiversity to biomass of certain species to even entire reef health. For example, we use this survey to predict coral bleaching episodes that have been occurring in Hawaii over the past year and a half or so. Here's actually an example of that. This rice coral here is bleached. This was actually from July, this past July, off the coast of Maui. We've also been looking at applying this system to terrestrial ecosystems, so essentially not only marine. And it's very powerful because it now allows anyone who's passionate about nature, anyone who's passionate about or about preservation and environmentalism to engage in this science, in this citizen science, and protect the environment. And at this point, you might be wondering, how exactly does this apply to science education, marine science education, either in the past but also in the future? And what ReefQuest has found is that when, like many of the other speakers have said, when you integrate the students into the environment, when their classroom is the environment, this is a picture of me collecting data in situ off the coast of Maui. But when you integrate the students in the environment in this way, the motivation with which they approach science, learning, and global preservation is drastically different. I found from personal experience, and actually why I founded the organization, was because conducting this research in field, I grew passionate about this environment. And that passion that I had was very different relative to the other classes I was taking in a classroom. We found that this is not only me, as I'm sure you've heard today, but programs that integrate you into the environment, that integrate you into this experiential learning, change the motivation, as I said, and enhance the learning. You delve into greater depth, better understanding of the concepts being taught. And so if this is sounding familiar at all, maybe it's because we're gathered here talking about shoals. I found that my experience in shoals, when your classroom is not the ordinary classroom, when your classroom is the environment, when your first homework assignment isn't filling out a form or filling out a paper, but is instead taking observation dives to explore this environment and find your passions within this environment. Here are just some of the photos I took over last summer. When you have this opportunity to engage so experimentally and with such depth in this environment, that is where true learning occurs. At least for me, I feel that way. And so, as an anecdote, I really don't have an anecdote about the past 50 years and how Shoals has changed, as I'm sure you might guess. Nor do I really have an anecdote about the future and the next 50 years. But what I do know is that from my personal experience, the education that I received at Shoals, the immersive experience, and the passion that it has developed within me and so many others, as you've seen today, for marine preservation, for science, for education, that and in that environment is really where true discovery occurs. And I thank Shoals for that. So thank you.